All right, this is a video on practice number 1, problems 7, 8, 9, and 10, and this is on the topic Unit 7, rational functions. Rational functions. This is going to be also for day 1. Just as a reminder, rational, this word here, means fraction. All right, so we're dealing with fractions made from functions. Let's go ahead and look. We're going to look at problem number 7 first, then problem number 8. These are both multiplication problems. Problem 9 and problem 10 are going to be division problems. All right? So a couple of things. One, if you have two fractions, for example, 3 multiplied to 2, or 3 over 2 multiplied to 5, let's say, over 7, the way that we would do this is we will multiply straight across. We'll multiply numerator times numerator to make a brand new numerator of 15. Then we would multiply denominator times denominator to give us a brand new denominator of 17. That's how multiplication works. Division, on the other hand, if you were to divide 3/2 by 5/7, what we need to do is to rearrange this according to KFC. Keep, flip, change. And what we're going to do is we will keep the first fraction just like it is. We will flip the second fraction, so this is going to invert itself to become 7 over 5. You could say multiply by the reciprocal. Reciprocal. Right? And then here. So then we've switched it to a multiplication problem, which brings it back to this set of guidelines or steps. And in this case, what we do is we would multiply straight across, giving ourselves 21 tenths. Notice that the results are different whether you multiply or you divide. Those are the basic rules of multiplication and division of fractions. Let's continue. Our first, let me do this, bring this into view. Problems 7 and 8 are here. We're first going to do problem number 7. Now, when we're dealing with this, the steps, always, steps, will be, number 1, to factor all numerators and all denominators. All right. Step number 2. We are going to, at this point, state the restriction. Or you can call this the domain. As you notice here, this problem is asking for the domain of this multiplication problem. You do that step 2 before you've canceled anything. All right? Step number 3 is to cancel, or to cancel. And that only happens if you have numerator, a factor in the numerator that is the same as the factor of the denominator. All right? And step number 4 would be to multiply any leftovers. These are the steps we're going to follow again and again and again. Notice there's nothing about division here, and what I do want to say, as I did in class, there is an extra piece of information about division. We will have to pay attention to this when we look at problems 11 and problem 12. All right, let's go ahead and look. Problem number 7 is right here. Step number 1 says we need to factor. So what we're going to do is we are going to factor all of the numerators and all of the denominators. Remember how we factor when a is equal to 1? We are looking for the things that will multiply to give you 24, but will here subtract to make -2. That's what we're trying to do for this particular one. I'm going to use colors in terms so I can coordinate. This part here will factor into. All right? So we're looking at 24. It's going to be 1 and 24, 2 and 12, 3, 8, get this out of the way, and 4 and 6. We are looking to subtract and make 2. That means we're going to use a -6 and a +4. That's what this part will factor into. Let's look at the next numerator. We're going to factor this part here. We need to do 6, and we need to add. And this time we're going to add to make 5. So we have 1 and 6, 2 and 3. We're going to add to make a +5. That is this set of numbers. So we're going to use a +2 and a +3. Right? Next, the denominators now. We're going to use blue. I'm going to use orange right here. Right? So I'm going to use 6 again. This time, however, I want to subtract and make a -5. Notice what we did in red. We had to add to make a +5. We had to add to +5. That's a 5. Here in orange, we need to subtract to get a -5. All right? So we still have 1 and 6, 2 and 3. In this case, we're going to pick 1 and 6. However, we need to make sure that we end up with a -5. So I'm using -6 and a +1, both in the binomial with x. Last, and we will use blue down here. All right? We're going to use 8. 1 and 8, 2 and 4. We're going to add and to make +6. So here what we have is we're going to use a +2 and a +4. These will add up to 6. What I'm going to do now is I'm going to rewrite the problem so it's a little easier to pay attention to. So over here, I'm going to have this fraction, right? I'm going to use the same color scheme. X minus 6, x plus 4. The denominator is going to be orange. I'm using colors, and it's taking a little bit longer because I'm trying to make sure that you all understand and follow the thought process here. Obviously, you guys do not need to use colors, but I do encourage you to if you find that it's useful. I believe that the colors will help you understand the concept, and once you get the concept, you can work a little bit faster. Don't work too fast because potential of mistakes is there. All right, so now we've factored. This is step number 1. We're over here now, right? Step number 1, we're done. Now what we want to do next, remember, going back and looking, step number 2, right here, we state the restriction before we do any canceling. So we need to look at all of the denominators. So from this part here, we understand that x may not equal to a +6. Also from this part here, we understand that x may not equal to a -1. If you have questions about this, what we are doing is simply saying that x minus 6 may not equal to 0. So either add the 6, and that's going to give us x may not equal to 6. That's how come I have this right here. Same for the -1, right? I'm saying that x may not equal, any of the entire denominator, plus 1 may not equal to 0. Minus 1, and we have left over that x may not equal to negative 1. That's how I got this part here. We can probably work a lot faster if we do not do the math, but make sure that you get the right result. So, from this part here, we know that x may not equal to a negative 2, and from this part here, we understand that x cannot equal to a negative 4. This is the entirety of the restriction, or you can call it the domain. So, step number 1 was we factored all parts. Step 2 was to state the domain. Step number 3, I'm going backward now. Step number 3 is to cancel. Only cancel if the entire factor in the numerator is the same as the entire factor of the denominator. What we have right here is we have x minus 6. So, whoops, that's too large of a highlighter mark. Let me use a smaller one and a different color. Let me use, no, I want to use, I don't have anything that works well. Okay, this x minus 6 will cancel out with this x minus 6 because it's identical, numerator and denominator. If we look here, you have an x plus 2 to cancel out with an x plus 2 here. Now notice what you've got here and here. Both of these are x plus 2's. They look like they're in different fractions, but it doesn't matter because one is in the numerator and one is in the denominator. All that is left is the x plus 3. So then we have what is left is x plus 3. That's from this numerator part. And then we have as the denominator x plus 1. That's from this denominator part. So our final result is going to be this is the reduced fraction, and then this is the restriction. Both parts are part of the solution. Take a moment, look at this. I encourage you to work this on a separate sheet of paper if you need. And we're going to move on. All right. Let's go ahead and look at problem number 8, I believe. Okay, going to go on down. Problem number 8 is similar. Again, what we're going to do is to factor the trinomials in the numerator and the denominator. Then we will state the restriction. Do not cancel unless you've stated the restriction. Then what we can do is to cancel and then do any multiplication if there is any left. So using colors again, we're looking at 35. So for this one here, 35, we know 35 comes from 1 and 35. 2 doesn't work, but we have 3 won't work, 4 won't work, 5 and 7. That's all that we've got. So we're going to subtract to make positive 2. So we know we're going to use a positive 7 and a negative 5. Switching colors, and use red down below. Not doing these in any particular order. 21, we have 1, 21, 2 doesn't work, 3 and 7. That's going to be all we get. We're going to subtract and get 4. So subtracting to get 4, we're going to use a positive 7 and a negative 3. Going to the back side of these binomials, we need to use 18 here. So we've got 18, 1, 18, 2 and 9, 3 and 6. That's all that we get. We need to subtract to make 3. In this case, we're going to use a positive 6 and a negative 3. Let's use orange in this part here. We need another 18. I'm not working with orange apparently. This is supposed to be orange. This 18 is orange. Same factors. So 9. But this time I want to add to get 9. So I'm going to actually use this same set, but they're both going to be positive. Please pay attention to the signs inside your trinomial. So for example, we have 18 in the purple and we have 18 in the orange, but this says in the purple we have to subtract, whereas in the orange we have to add, and we're adding to different values. Pay attention to those details. So what I'm going to do is take a moment and rewrite this on the right-hand side. Since I've factored it now, I'm just rewriting the multiplication problem. And this denominator here, second numerator, and second denominator. Now, step 2, again, state the restriction right now. From this part, we understand that x may not equal to a negative 7. From this part here, we understand that it may not equal to a positive 3. Now, from the orange, we get that we may not equal to a negative 6, and we're not allowed to equal to a negative 3. Here. So one way to write this is to list out each of the individual terms. Another potential way would be to say that x may not equal to, you can have negative 7, you have a 3, but you have plus or minus, because you've got, let me write that more legibly, plus or minus the 3, because you have a negative 3 here and you have a positive 3 here. You can compress them into this one phrase, and then you can have a negative 6. Either way is fine. Now, we get to do our canceling. So we understand that this x plus 7, I'm going to use a smaller highlighter, x plus 7 is going to eliminate with this x plus 7 here. We see an x minus 3 here. This x minus 3 cancels here. X plus 6 in this denominator, x plus 6 in that numerator. And what we are left with as our final result is going to be x minus 5 divided by x plus 3. Here we are done, and either one of these are going to be the domain, or the restriction on the domain. Fair enough? All right. The next two problems are going to be division problems. Slightly different. They have a little extra piece inside. So again, with these division problems, what we have to remember is we're going to keep, flip, change. So we will keep this first fraction. We will take this fraction here and we will flip it over, and we're going to change this guy to multiplication. Let's go ahead and get started. Problem number 11. The steps to start off with are exactly identical. First, we're going to factor everything. So this here, we actually have GCF factoring happening here. I see this first term and this second term have a GCF of x squared. Once I've removed x squared from this first term, what I'm going to have is just 6x. If I remove x squared from this last term, I'm going to have just plus 7. That's how this particular binomial will factor. Looking at the denominator here, I also see a GCF. So I understand that I can take 3 out of each of these, leaving 4x minus 1. This blue phrase needs to multiply back to give us that denominator if we so chose. Now, in purple up top here, I see that the common denominator, the greatest common factor, sorry, I misspoke, the greatest common factor is going to be simply x. When I divide this, I will have 6x, and I will have plus 7. Now, underneath this denominator here in orange, I see that the greatest common factor is going to be, you could divide them by 3's, but I want greatest common factor. And I need to remember from multiplication that 4 times 9 is 36. So I'm going to take the 9 out, and I'm going to end up with 4x minus 1. So now, what we're going to, I'm simply going to rewrite this math problem over here on the side. It's going to look like this, writing the factors. I don't need this GCF word anymore. 6x plus, it's a little illegible, 6x plus 7. Here I have x times 6x plus 7. I have 3 times 4x minus 1. And I have 9 times 4x minus 1. Right now, we have a division problem where I have two denominators, and I have to state the restriction now. Every time I have a denominator, I have to state a restriction. So, based on this part here, let's switch to blue. I understand right now that x may not equal to a positive 1/4. If you have questions about that, what I've done is I took the 4x minus 1 and said you may not be equal to 0. Then you add the 1, leaving 4x that may not equal to 1. Then if you divide by 4, you find that x may not equal to a positive 1/4. That's how I got this. All right? So, going to look at the next denominator. This denominator happens to be an orange, and this is identical, so I'm just going to have the same negative 1/4 or positive 1/4. So I've got another 1/4. It's the same number. Now, going back to the rules of division. Remember, the rules of division say that we have to use K, F, C, we have to keep, we have to flip, and then we have to change. What that means is I'm going to keep this first fraction just like it is. So just copying the first one. Now, this symbol here becomes multiplication, right? This fraction needs to flip over and become this. 9, 4x minus 1 divided by x multiplied to 6x plus 7. That's what our new second fraction is going to be. We now have a new denominator piece right here. We need to identify the restrictions from this part of the denominator. Notice this denominator has two terms. It has a term here and it has a term here. Each of these terms, this one and this one, need to be included in our restriction. So, what we're going to do is we will say, for this one, we would say that x may not equal to 0. There's no more math to do here, so I include 0 as part of the restriction. This, I would say that 6x plus 7 may not equal to 0. You subtract the 7, you subtract the 7, and you're going to be left with 6x may not equal to negative 7. If you finish by division, you would have that x may not be negative 7/6. This concludes the domain or the restriction. So, again, we have factored Step number 1. Step number 2, we state the restriction. Now our job is to do some elimination or canceling. I'm erasing this because it's possible that you could do this on the side, the restrictions, or you could answer that from what you know the pattern is going to look like. So based on this, I see a 6x plus 7 here. That's eliminated with this 6x plus 7 here. I see 4x minus 1 eliminating with 4x minus 1. Now what is left? What is left over? And we're probably not done with our canceling. We have x squared times 9 over, sorry, let me say that a different way. X squared over 3 multiplied to 9 over x. Now we're not done because I understand that this 9 can become 3 times 3. This x here is really x times x. I see that this x here will cancel out one of these. I see that this 3 will cancel out one of these. So our final bit of work, this x will cancel out only one of these. This 3 is going to cancel out one of these. What we are left with is 3x, and that is it. So our final result, this whole fraction, once we have factored it, changed it to a multiplication problem, and then multiplied, is going to reduce to just 3x, but provided that you state this restriction saying you may never use a 1/4, a 0, or a -7/6 in the original problem. And we are finished. Next one. Same process. In this particular case, our factors are going to be based on trinomials. So, this red here is going to be, we're working with 6. We need to add to make -5. So in this case, we're going to use a -3 and a -2. Because those will add to get you your -5. Here we have 18, working in this denominator here. 18, 1 and 18, 2, 9, 3, 6. I need to add to get a -9. In this particular case, I'm going to use a -3 and a -6. Being good at factoring helps. This denominator, I'm working with 20. 1 and 20, 2 and 10, 4 and 5. I need to add to get a -9, so I'm using a -4 and a -5. And in the numerator of this side, I'm working with 8, which is 1 and 8, 2 and 4. I need to add to get a -6. In this case, I'm using a -2 and a -4, right? So I'm going to rewrite this. I just paused the video and rewrote it for you. So this is what you would rewrite as. Now remember, this is simply step 1 done. Step 2 says we must now identify the restriction. Please remember, with division, our restriction's a little more complicated than with multiplication. So, based on this, we know that x may not be 3. We also know, based on this, that it may not be 6. On this part, we know that you may not be equal to 4. This knows we may not be equal to 5. But with division, remember, we have to keep, flip, change. This last one is going to flip himself over, allowing this purple set to become a brand new denominator. So when we are done, this purple x, oops, I'm in the wrong color, x minus 2 and x minus 4 are going to find themselves in the denominator of this second fraction. Notice what I've done. I've simply turned this second fraction upside down, right? So this first would change to multiplication, and the red x minus 3 stays where it is, along with his partner x minus 2. This denominator does not change. So now I have two more pieces to consider as my denominators, which includes two more numeric restrictions. So I understand also now that I have a positive 2, and this 4, it's a negative 4 here, but the restriction will say, hey, you can't use a positive 4. It's already represented. So I'm done with the restriction part. Now comes the fun part of canceling, right? I'm in multiplication mode. This will cancel with this. This x minus 3 is the same as x minus 3. X minus 2 has a partner way over here. X minus 4 has x minus 4 above, and the two parts we are left with. We're left with x minus 5 to be divided by x minus 6. This is the reduced fraction. My pen's acting goofy, sorry. Or you might say simplified. But this is the restriction or the domain. All right? Take these problems, practice them, bring questions to class.